Mr. Hammer back with number 8 from section 10.3. Write an algebraic expression for each statement. 3 more than a number. Well, more than is plus, so 3 plus a number. 3 more than a number. Now we have a number added to 3. Well, added to is also plus, so we have a number added to 3. So n plus 3. 3 less than a number. So 3 less than a number. So this gets tricky. So let's say my number is 10. 3 less than 10 would be 7. So what they're saying here is I'm doing that number minus 3. A number subtracted from 3. So let's say my number was 1, and I'm subtracting 1 from 3. That would be 3 minus 1. So I have to write 3 minus my number. Remember, when I see subtracted from, the order switches around. The 3 goes to the beginning, and the number goes to the end. So I have 3 minus my number. Now, how are the expressions in part A alike, and how are they different? Well, these two here, they're really the same. When we add two numbers, we have a property called transitive. So let's say my number is 2, in this case up here. Well, 3 plus 2 is going to give me 5, in this case here. So 3 plus 2 would give me 5. Whoops, lost my pen. Frozen, frozen, frozen out. Let's see if I can go to my mouse. So 3 plus 2 equals 5. I've lost all my... Oh, here we go. I'm back, but with a different pen. Let's see if I can go back to my regular pen. And 2, if n is 2, 2 plus 3 also equals 5. Let's try that over here. Let's say n, for the subtraction case, is also 2. So again, we're doing n is equal to 2. So if n is 2 over here, we would have 2 minus 3. 2 minus 3 is negative 1. We haven't covered that yet, but if you start with 2 degrees Celsius, if you're at 2 degrees Celsius and you go down 3 degrees, you're going to end up at negative 1. But if you do 3 minus 2, that gives you positive 1. So notice that 3 plus n is the same as n plus 3. So when you add two numbers that are the same, you can switch them around. The 3 can go in the beginning, or the n, and the n can go in the beginning or the end. But when you have subtraction, you can't switch. N minus 3 is not the same as 3 minus n. You get different results. Let's move on to number 9. Rate each expression in words. 6h plus 5. So 6 multiplied by a number added to 5. Notice we don't need to write then add to 5 because order of operations tells us we have to do the 6 multiplied by a number first regardless. Let's look at the next one. A number subtracted from n, or a number decreased by 3, divided by 4. Well, let's look at that. So a number decreased by 3, which is the same as subtracted, and divided by 4. The problem here is order of operations says we don't do subtraction first. We would then do 3 divided by 4 first. So in order to make sure we do a number decreased by 3, we would have to add a word to describe the brackets here, which would be, or the fact that they're on top, which would be a number decreased by 3, then, not and, we would write then divided by 4. Okay, that tells us that first we have to do a number decreased by 3. What about the next one? So a number, which is t, a number divided by 4, added to 12. We don't need then this time because we have to do the division first. Addition always comes after. Let's move on to D. So we have 3 beside a bracket and then x minus 3. Well, anytime you have a number beside a bracket, that actually means 3 times whatever is in my bracket. So it's going to be 3 times x minus 3. We have to do the x minus 3 first. Let's write it in the tricky way. 3 subtracted from x. So 3 subtracted from x which would be a number. 3 subtracted from a number, then multiplied by 3. So what have we got here? A few things. We took the trickier way to do subtraction. 3 subtracted from a number, that's this part. We've added the brackets to say we do that first by saying then. So we have to do this part first here. Then after we're done doing 3 subtracted from x, then we can multiply by 3. Now recall, for this question we could also write it like this. We could write a number decreased by 3. If you want to do it, this is the easier way to remember. A number decreased by 3, then multiplied by 3. You could do it that way as well. Either of these ways would be acceptable. Okay, let's move on to E over here. I will make this all smaller if I can. Whoops, the number didn't work. Let's just clear the page. So here we have a number divided by 5, and then a minus, and then 32. So 32 subtract a number divided by 5. Let's try that. 32 decreased by, I'm going to write decreased by instead of subtracted, decreased by a number divided by 5. Let's see if order of operations works here. 32 decreased by a number divided by 5. So one might think that I could do a 32 decreased by 5 first. Sorry, 32 decreased by a number first. So that would be a number decreased, 32 decreased by a number divided by 5. You could think that maybe you're reading it like that. But order of operations tells us we have to do this first. 32 decreased by a number divided by 5. So we have to do a number divided by 5 first, which is what it says here, and then we're decreasing 32 by that. So we don't need the then in this case. Let's look at this one over here. So in this case, we have the number divided by 5 first. So a number divided by 5, and then we would say it would be decreased by 32. So let's look that over. A number divided by 5, that's this part, decreased by, that's my negative, minus 32. That works. We're all good. So that's number 9. Let's move on to number 11. We're going to skip 10. A pizza with cheese and tomato toppings costs $8. So my pizza costs me $8. But there's a cost for my toppings. And my toppings are going to cost $1 each. So I'm going to be adding my pizza. That's my, what we call often your flat fee. Flat means it doesn't change. No change. It stays flat. Like if you think of something that's flat over time, the price stays the same. It stays $8, doesn't go up. Okay? So you've got a flat rate, then you've got a charge of $1 per topping. So $1 per topping. So if we had, let's just erase this, if we had 8 toppings, we would have $8 plus 1 times 8. Right? We would have $8 plus another 8, because we had 8 toppings, so $8 for our toppings, which would be $16. So how could we write that as a general rule? Well, we could say we're going to pay $8 plus we're going to pay $1 times the number of toppings we have. And we could just call this number, in this case we chose 8 toppings, but we could choose any number of toppings. That's the variable here. So we have a variable, and we have the rate, which is $1 that we pay for every topping that we have. And it's called a variable because it changes. In the word variable, we have the word vary. And vary means to change. So this amount of toppings is constantly changing. So we would have, again, we have 8, which is our flat fee. That does not change, plus 1, t. This is our variable that changes because it varies. It changes. And then this is the rate, how much we pay for this thing that changes. So if we had 8 let's say 7 toppings, we'd do 1 times 7. 8 plus 7, our pizza would cost $15. If we had 2 toppings, it would be 8 plus $1 per topping times 2 toppings. So 8 plus $2 for our toppings are $10. So this thing here, this expression, allows us to figure out how much a pizza would cost depending on how many toppings we have.